Dear Professor, I would like to submit my homework 7 sharp number 2 about explain closed loop control system and how does it work. Like this, like these figures. Closed loop control system is a mechanical or electronic device that automatically regulates a system to maintain a design state or set point without harming in interaction. Its its carry its characterized by monitoring and adjusting the output of the system through feedback mechanisms so that the system maintains the desired performance under changed environmental conditions. Unlike unlike an open-loop control system, which operates without feedback, a closed-loop system continuously monitors the output and adjusts its input to reduce the difference between the actual output and the desired set point. As sure as in the feature, the common the common sys- the command the command important in command singles input in container. The container set a single a single to actuator actuators such as a motor, reducer, encoder, and so on. If there have many errors, the the fed the feedback system get a single and set the single to controller calculated by PID or PLC controller. The controllers set a new single to the actu- actuator, and so it goes until you get the right single. For the closed loop control system for a rotational system, the system is designed to control and maintain a desired rotational position, velocity, or torque. The components of a closed-loop control system include four parts, which are controller, actuators, rotational system or plant, and sensor feedback. For controller is a device or algorithm, for example PID controller or PLC controller, that calculates the necessary control signal to reach the set point. For the acu- acu- actuator is that the device that moves the system. And in the regional system, for example, is plant. This could be a motor, for example, DC, AC, or servo motor, that generates the torque to case rotation. For the rotational system or plant, is that the actual mechanical system being controlled. It could include gears, nodes, motors, and other mechanical components. For the sensor or feedback system, is a sensor like a encoder, gyroscope, or tachometer that measures the actual state of the system, such as the rotational angle, speed, or position. Next, I will briefly explain the system how to work. A design a designed rotational state, like position, or velocity, or torque, is set as the set point. The system measures the current rotation state using the sensor. Calculated arrows. These arrows are used to determine how much the control signal need to be adjusted. The controller, such as PID or PLC controller, process the arrow and determines the proper proportioning control signal to apply. The control the controller set the right signal to controller. The sensor continuously measures the current state of the system and provides feedback to controller. The system continuously updates the arrow based on the feedback, creating a loop. Now I will introduce the closed-loop control system for rotation system, how to work continue. In the feature, it's 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 controlled by PLC. PLC this PLC is an industrial digital computer designed to control manufacturing process, mechanical, or automation system. It is commonly used in industrial environments to manage complex processes by receiving inputs, processing them according to a program, and generating outputs that control various devices like motors, valves, and nets. In the future, there have PLC controller, the motor, usually a stepper motor, servo motor, or another controllable motor with position feedback, and the motor driver for receive control signals from the PLC to drive the motor. The indicator or feedback device is a sensor, like a retro encoder, attached to the motor shaft, providing real-time position feedback to the PLC. When the desired motor position is set, the encoder or feedback sensor reads the current motor position. This data is sent back to the PLC. The PLC program calculates the error. The error equal set point minus measured value. If the set point is 19 degrees and the motor's current position is 70 degrees, the error is 20 degrees. The PLC executes a control algorithm to minimize the error. The algorithm determines how to adjust the control output, such as speed, director, and so on, based on the error. The PLC generates a control signal based on the PID calculation, such as pulse signals along voltage, and then the motor driver used the control signal to drive the motor and adjust its position according to the new control signal. The feedback loop continuously updates the current position from the encoder. The PLC recalculates the error and adjusts the output until the motor's actual position matches the set point. Okay, it's the closed loop control system for rotation system how to work. Next, I will introduce the closed loop control system for a linear system. A closed loop a closed loop control system for a linear system is designed to control and maintain two desired linear position, velocity or force. Linear systems often include controlling a motor, actuator, or other device to move along a straight line. The components of a closed-loop control system include four parts or so, which are controller, actuators, or pneumatic cylinder, or another electrical mechanical actuator. The function of other parts are same. The difference between rotation system is actuator. Actuator is linear motion. Next, I will briefly explain the system how to work. A desired value for the system is set. This could be a target position, for example, 100 millimeters, or speed, such as 5 centimeters per second, or a force. The sensor the sensor measures the current state of the system. The controller the controller the controller processes the error and determines the control signal need to drive the actuator actuators to minimize the error. The error is calculated. The controller sends a control signal to the actuators, such as a voltage or current. The actuators receive the control signal. and move accordingly. It may be move faster or slower, or just force to current the arrow. For example, a linear motor could move to bring the system to the target position. The sensor continuously measures the current linear state and feeds it back to the controller. The system continuously updates the arrow based on the feedback, allowing for continual adjustment until the arrow is reduced to zero or near zero. In the future, it's are controlled by PLC. There have PLC control the motor, PLC control the motor and the motor driver, and the encoder or feedback device. Linearly closed-loop control works similar to rotation closed-loop control, except for the way of motion. Under the control of PLC, the linear motor makes the actuator move along the collecting rod, moving side to side. For example, if you want the actuator to move 200 millimeters, the set point is 200 millimeters. The sensor measures the current position. If it's at 150 millimeters, the arrow is 50 millimeters. The controller calculates the control output based on the arrow. Proportional multiplies the arrow by a constant to create an immediate response. Integral accumulates arrow over time to remove steady state. Description. Derivatives produce future arrow based on the rate of change of the current arrow, and then the controller sends a signal to the linear motor. The motor moves the actuator close to the 200 millimeter mark. The sensor updates the current position. If the actuator is now at 190 millimeter, the arrow is reduced to 10 millimeter. The controller adjusts the output accordingly, turning the movement until the actuator reaches the 200 millimeter position. Okay, this is my introduction of about closed loop control system. It's my homework 7 sharp number 2. Thank you, Dr. King.